and I will get going. Thanks for planning this event today. So, intelligent query processing is a huge feature. It was introduced in SQL Server 2017. It has a lot of components, a lot of different things that make our queries faster and make our lives easier. So the purpose of this presentation is to really go over what the different components of it are. And I'm going to link to other presentations that are going on today as well. There's no reason for me to kind of reinvent the wheel that somebody else is already talking about. So thanks for having me here. I'm Edward Pollack. I'm a data platform MVP. I work as a data architect over at Datto, right near here in Albany, New York. I've done a whole lot of organization of SQL community events. I've published books. I have a patent. I've written lots of articles, done a lot of things. So I enjoy this. It's fun. It's what I like to do. Learning about how this stuff works makes my life better, and I find it fun. So that's who I am. Just if you want to reach out to me with questions, if you're interested in anything, let me know. Just so you know, I've been sick for the past week. I'm doing a lot better now. My voice isn't 100%. So if at any point I don't sound 100%, just don't hold it against me too much, please. Otherwise, thanks. Cool. Here's the event today, and some of this has already happened. In fact, half of it has already happened. So I may reference it as happening in the past, and there's some more going on later, some more deep dives into individual intelligent query processing features. I'll mention those as well. We're right in the middle right now, so thanks for being here. For you, it's after lunch. For me, it's right around breakfast. It's kind of the fun of this whole virtual thing. So thanks for planning this event. And there's a lot of great stuff going on today, and it's all recorded, which means you can look back on it later. Back in the beginning, intelligent query processing was simple. This is the chart of what it looked like. It had really only a handful of features, and they were almost all column store related. Adaptive joins, memory grant feedback were batch mode only, which at the time just meant there was no batch mode on row store. That meant column store. And interleaved execution was the only thing not column store, and that was really just the multi-statement table valued function optimization. So it was pretty simple. It was straightforward. There wasn't a whole lot going on. And if you weren't using column store, there probably was very little that impacted you in your workloads. Use SQL Server 2019 and more got added. A big branch for adaptive query processing, allowing for things like adaptive join, which again, that was only in column store. The memory grant feedback made its way to row store, and they added interleaved execution. So this is getting better. Sorry, well, I just read the whole thing backwards. Wow, this is what happens when you're sick for a bit, isn't it? Those are all the 2017 features. 2019 added the approximate function for count distinct, Scalar UDF inlining, which improved the performance a lot there. Batch mode made it to row store, which is a huge deal. It's enterprise only because you don't have batch mode on standard, but a huge bonus. And they made table variables better. So a lot began to happen. This chart began to get bigger. It's still sensible, but it's getting bigger. And then we hit 2022, and now the chart is giant, and there's a lot of new features, and a lot of these new features are huge. These are things that really take problems that have been affecting us for years and years and years in query performance and solve them, or at least try to solve them very well. Things like parameter sniffing, something that's bugged us for ages. It's the sort of topic that you can present on now. You could have presented on it 20 years ago. It's always been an issue, and now they're trying to solve it. So a lot of huge features here that helped us, like, the feedback features that we talked about later, those are huge. They can take problems and execution plans that happen over and over and over and resolve them. So just huge bonuses, huge benefits that we can have in our workloads. And 2022 added them, and now this chart is pretty big. So I'm going to dive in and really just talk about different pieces of this, what they are, what they do for us, what you need. And I'm going to talk about this in the perspective of 2022. If you don't have SQL Server 2022 yet, these are good reasons to upgrade. But you can use the previous features that are available in your version of 2017 or 2019. You have some of this, and it's available to you. And you can check these charts just to kind of know what is available to you. The big problem really that we faced before all of this was that you have the query optimizer. It's an important piece of software, and it needs to generate execution plans fast. Fast is the key. You can't wait a minute. You can't wait 30 seconds. You can't even really always wait a second for an execution plan. It's got to be fast. It needs to do it quickly. And it's relying on past data. It's relying on stats and metadata and pieces of your query, constraints, whatever, to make decisions. And that's all stuff in the past. And it is helpful, but it may not give it enough information, especially as queries get bigger and data gets bigger. It may not be good enough anymore. To add on to the trouble, your execution plan was a static structure. It generated it before your query was going to execute at runtime, and then it was reused over and over in the future. So if the execution plan was correct, it would be correct in the future. If it was problematic, it would be problematic in the future. If it was sometimes okay and sometimes bad, then it was sometimes okay and sometimes bad. And that's challenging, 100% challenging. And because of that, we had many issues that came out of it. Things like parameter sniffing and bad plans and bad cardinality guesses, and it chooses the wrong parallelism, it chooses the wrong join type. Those things happen, they get stored in the cache, and then those problems live on past us. And the real challenge here was that if the optimizer made a bad choice, or if it just made the best choice it could and it wasn't the right one in the end, it couldn't do much about it. It couldn't say, oh, I goofed before, let me fix that. It didn't get that option. And that was really the challenge that we had here. And so intelligent query processing really takes the optimizer and gives it memory, feedback, and the ability to think into the future, think into the past, and make better decisions. And that's huge. We don't want to cache problems forever. We want to fix them. That's what a human would do, right? If you solved a problem and discovered you solved the problem kind of poorly, you'd go back and fix it and make it better. That's what you would do with anything. And so the optimizer is now going to behave a little more like this. As a bonus, IQP threw in a bunch of other features too that just help us in general get better performance. And that really is our solution. We want query processing to be more dynamic. We don't want it to be a static thing where you pick the solution, you try it out, and no matter how it goes, you keep doing the same thing over and over. It's not really a very effective way to do things, and it just results in mistakes. What we can do now is do one of a few things. One, we can add decision points into our processing and say, you know what, we know looking at this before even make an execution plan, we know there's going to be some difficult decisions in here. We know that I'm going to make a choice and it may or may not be right just due to the nature of the data and everything in there. The query costs are very close. You know, what if you're picking between two query plans with very similar costs? Which one's really the right one? And so the execution plans can have decision points in them that say, all right, well, depending on how things go at runtime, you can do this, or maybe this. That's a big deal because now I can make a better decision, getting more data and more information later. We can also go back afterwards and say, you know what, we made a lousy plan, let's make it better. We can actually identify it based on a bunch of criteria and go back and fix it. And one of the biggest keys to all of this with intelligent query processing is, like, you know, the side of the new functions that were added. Obviously, if you're going to use a new function, got to use a new function. But outside of those, everything here doesn't require code changes, which for developers, for architects, is a huge deal. Being told, hey, we can make your app faster without you doing anything is music to their ears. They love that. And that's a huge deal. I don't have to go and add new stuff to my code. I don't have to go swapping out functions. I don't have to go enabling special isolation levels or anything like that. I can just keep running my same code and some things will get better. Now, there is some gatekeeping here in terms of how you enable, and it's really going to be compatibility level. The chart earlier showed how different features were available in 2017, 2019, and 2022. And based on that, your compatibility level will gatekeep those features. If you have your compatibility level on a database at 2017, then you're only getting those features. If it's set to 2019, you'll get those plus the 2017 features. And if it's set to 2022, you get everything. And that's how it'll be in the future as well. That's how, in general, like, query performance and optimization is handled by compatibility level, is that you set it, you get the behavior of that version of SQL Server. It's intentional, it's by design, and it's what you want. So if your compatibility level isn't high enough, doesn't matter if you're on 2022 or not, you're not getting all the features. So just keep that in mind, that if you're upgraded all the way on the latest and greatest, if you don't have the correct compatibility level, you will not get the features of intelligent query processing for that version. There's a lot of presentations earlier on Query Store. Query Store is huge, very, very helpful in general. And for some of these features, it's required, and in one case recommended. But you want Query Store for some of these features, especially the new ones. You can't have feedback and persistence without Query Store to store that data somewhere. It provides a really nice ability for things to outlive the plan cache. And so for something like, for example, degree of parallelism feedback, the details of what happens when those decisions are made will get stored in the Query Store. And so now, even if your plan is evicted from cache and goes poof forever, you still have information about it in the Query Store that can be used to make that better plan in the future. So keep in mind that query store is required for some of the newer features. In general, it's a recommended thing to have if you can. One note, of course, I threw this in the bottom in a tiny font. I get a laugh out of it, is that intelligent query processing attempts to fix the mistakes the optimizer makes. It is not intended to fix the mistakes that you make or I make. It can, it might help us, but if you write some crazy query with 100 tables and a whole bunch of crazy joins and really weird where clause, it's going to perform about as well as you think it will. If you write bad code, it will perform probably badly. So this doesn't solve bad code. If you have an out-of-control ORM that generates wild code, if you have just some old legacy code that's bad and inefficient, this may not fix it. It might help, but that's not the intention of this. The intention is not to make your code smell better. It's just meant to improve query performance when the optimizer doesn't make the ideal decision. Again, this whole presentation is on 2022. Everything we're talking about is 2022. Always just check and verify. It's really important. Just verify what you have currently. What version do you have? What compatibility level your database is set in? That will tell you what is available for you to use. There's a presentation on this earlier already. Adaptive query processing is a key piece of intelligent query processing. This allows SQL Server to make decision points, insert them into the plan, and then when more information is available later on, you make those decisions based on it. For example, adaptive joins allow SQL Server to say, I don't know if I need nested loops or hash match, so I'm going to say, let's make up a plan that can use either one. And based on the cardinality at runtime, we'll pick the correct one based on the input size. So we know what they're good for, each type of join, but we're not quite sure what the end result's going to be in terms of which is needed. Adaptive query processing is very helpful because it can allow, when you have query inputs that change very often, you don't want the same plan necessarily, right? If you have an execution plan that says always use a hash match, well, if one input is giant and one is small, that's going to look very different than if you have two giant inputs or two small inputs. And so the ideal join may change. So if you have workloads that are very inconsistent, and that really is in general in intelligent query processing, what it's really built for are inconsistent workloads. The more wacky your workload is, the more inconsistent it is, the more row counts go up and down and things change a lot, the more you'll benefit from this. Adaptive query processing is a whole suite of features in here that basically handle inconsistent performance, where things just change a lot, which isn't unreasonable. Systems that deal with, workloads like order processing, you might have one, you might have 100. You might have an order that has one item in it or 100. You don't really know until runtime. And trying to manually code around and make things work is hard. Having a system that can do it for you is great. And what really ends up happening here is if you have execution plans that are being looked at where the costs are similar, because ultimately the optimizer is a chess master. It's going through lots of execution plans, assigning costs to them as to pick the best one. And sometimes the best choice is obvious. You have your best plan as a cost of 1, and all the ones below it have a cost of like 1,000,000. And the optimizer immediately says, all right, we know to choose the one with cost 1. It's no question, right choice. And that isn't always the case. Very often we run into problems where the top 5 plans all have values of 1 and 1.01 and 1.1, and they're closer together. In those scenarios, as somebody just using SQL Server, you won't really notice what happens under the covers, but it picks the best one. But if the best one was only a hair of a percent better than the second one, that second one might have been better, or it might not have. You don't really know. It's a cost-based system, but this helps a lot in those scenarios where suddenly we realize, you know what? There's a handful of options. They're all very similar. We can at least account for a couple of them here. And maybe if one ends up being better, we can use facts to make a good decision. So that's adaptive query processing. It's a whole suite of features. It's very powerful. And it helps us a lot with inconsistent workloads. And again, this is just there. It works. It's there. You have it available to you to use without any code changes. If you are interested in more, check out the recording from earlier today. There's a whole session on adaptive query processing, which is why I'm not going to dive into it here. It's already been dived into today. So check it out, learn more. It's a really cool feature, and it can really help a lot. The next kind of piece to intelligent query processing is feedback. This is the second piece. So you can have decision points at runtime that help us make better choices because we know that sometimes things are close. Now, what happens next? We run a query and we want to see what happens. What if it doesn't go well? What do we do? And that's feedback. This is a huge piece of intelligent query processing. So now we're going to say, I've executed a query and the plan didn't go so great. What happens now? And query processing feedback, and all the feedback features you see, everything in IQP that has the word feedback in it is talking about this. It's talking about the fact that it's going to go back and adjust the plan when it makes a bad choice. So it makes a decision, executes, and says, wow, we chose parallelism 4, but we did a whole lot of CX packet waits. We had a whole lot of parallelism waiting. It didn't really seem to work out the way we thought it would. What do we do now? Before all this, the answer was you keep doing the same thing over and over forever. You made a mistake, and we're going to keep making the same mistake and getting punched in the face over and over forever. But with feedback, you don't have to do that anymore. With feedback, we can now simply say, hey, we chose MDOP before. We know we did a whole lot of waiting on parallelism, which is clearly a sign that we chose the wrong MDOP. So, all right, let's adjust it down to 2 and try again. Oh, okay, the weights are almost gone. Great, let's just fix it to that and keep doing it that way and call it a day. Alternatively, if you had adjusted it down from 4 to 2 and maybe the parallelism weights went away, but the query took much, much longer to execute, SQL Server might say, well, it was a nice idea. We'll just go back to the way it was before. Or try 3 maybe. But that's what this does basically. Feedback allows SQL Server to use execution information to go back and make the plans better. And it usually won't do it after one shot. It'll very often sample a handful of times, which is why if you're like playing around with this and testing and you run a query and it has terrible cardinality, it doesn't fix it in the next run, it's not because this feature is not working. It'll intentionally sometimes sample a handful of times first because it wants to be correct. Running a query one time means you have a sample size of 1. And a sample size of 1 is not always the best way to be sure you're making a good decision. So it will use multiple executions, but again, this is a good thing. Query processing feedback is a way for SQL Server to take information about how things executed and go back and make them better. And to go back to the big diagram from earlier, we're looking at query processing feedback. This is a lot of features. We're talking about memory grant feedback, cardinality estimate feedback, degree of parallelism feedback. Those are 3 huge pieces to it. And that means, and these are the biggest mistakes that happen pretty much out there, are these things. These are things that can just bury us in bad decisions, especially cardinality estimate feedback. How often have you taken a look at an execution plan and you've seen a scenario where your cardinality, you return 2 rows, but it estimated 1 million rows, or you see it in the middle of your plan somewhere for one operator. Thought it was going to pull 10 rows from a table, but it pulled 1 million rows. And we know that impacts your execution. If it makes a bad decision there, it affects everything downstream as well. So these decisions especially will benefit you if you have larger, more complex queries, because if you have a query execution plan that has 20, 30, 40, 100 operators in it, and an operator early on makes a bad decision, everything downstream from it gets mucked up as well. So feedback really helps kind of fixing pieces of the plan that are wrong, and then everything downstream gets better as well. It's not included under the umbrella of feedback, but it really is feedback, and that's parameter-sensitive plan optimization. This feature is huge. This is probably one of the biggest adds in 2022, and it is worth talking about. It's worth being happy about. It's worth testing. This feature really does take the problem of parameter sniffing, and it addresses it. And this has been with us our entire lives, right? Parameter sniffing. You have a proc, you have big results, little results, different parameters result in different quantities, and you get the same execution plan every time. But that isn't necessarily what you want. This allows the query optimizer to do a really cool thing. It can now say, you know what? This query appears to be parameter sensitive because I know that the query costs are very similar for different paths based on cardinality. And I know that if I have a cardinality of 10, I have a wildly different plan from a cardinality of 100 and a cardinality of 10,000. So what do we do? If SQL Server can identify that as an at-risk parameter, a sensitive query, it will actually create query variants. So what it's going to do is it is going to say, all right, let's create 3 ranges here. Range 1 is 0 to 20. Range 2 is 21 to 100. And range 3 is 101 and greater. And it's going to make a separate plan for each of those cardinality ranges. And this is before the query executes, so before you're at runtime, doing your thing. It's after you've hit F5, but before you're actually, getting results back. And so SQL Server creates what's called a dispatcher plan. A dispatcher plan is a special component gets added to your execution plan that includes the instructions of which plan goes to which cardinality range. And then that is part of your plan now. So, and kind of like how you had adaptive join, where it would wait until runtime to pick the join based on information, now you're going to have this dispatcher plan and information about which plan to use, and it's going to kind of hang on to this until runtime. And then when the actual cardinality comes in and we know what the input looks like, SQL Server says, okay, the input's 100. Use this plan. The dispatcher plan will send it off to use that query plan. This is a huge deal. This really means that if you have a parameter-sensitive query, something that you know is problematic, this can automatically solve it. So no longer are you out there tweaking queries and trying to fix them and make them better, because you can't always. Sometimes you can. Sometimes, parameter sniffing is the result of bad code. That's very often the cause of it, but not always. And you don't have time to go out there and fix every single mistake in the world. So this is a way to automatically fix parameter-sensitive plans. It's a hugely important feature. It's in 2022, but it's a reason to upgrade for many people. If you're suffering from parameter sniffing, this is something that's really killing you. If it's wasting lots of your time and other administrators' time, this is a sort of feature you want to test and get out there, look at it, and see, does this help? And odds are it will. And when it does, it will save you a mountain of time, because now you don't have to go out there investigating every single parameter sensitive issue that happens. And they aren't all even bad code. Sometimes you simply have processes that have wildly different inputs, and that's life. Sometimes I return 1, sometimes I return 1,000. And that isn't always wrong. Sometimes it's okay, and this solves that. So this is huge. And your execution plans will be reconsidered for each query variant as well. So if you have 2 similar queries come through, they may get treated differently as a result. And so again, this is a really good thing. If you have similar queries that aren't the same, they would normally get separate execution plans. They can each get different dispatcher plans, different sets of query plans, and they'll make their decision points and decisions differently. So this is huge. This is a giant, huge add to SQL Server, and I'm not just drooling over it because I like SQL Server. This really is a huge add. Parameter sniffing has made our lives miserable for years. It can make our lives miserable far less now. And there's more feedback out there. There's 2 more sessions later today on feedback. So if you're interested in degree of parallelism feedback, there is a whole deep dive into it later today. There's also an entire session on cardinality estimate feedback and parameter sensitive plan optimization. So if this wasn't enough for you, just hearing kind of the overview, there is a whole lot more later for you to learn about and dive into. And now the last piece of this kind of triad. So first you have putting new decision points into your execution plans, and then you have feedback, which lets SQL Server say, all right, we're going to make decisions and we're going to then go back and try to fix them later if we made a bad choice. The last piece of this that makes this powerful is persistence. Feedback persistence means we're going to store the results of what we did in the query store. And what this means is not only can we then go back and fix things later, but if your plan leaves cache, which will eventually happen, all plans leave cache eventually, especially if you restart a server, for example, plans leave cache, but the query store doesn't. The query store does not go poof, and so it has all that information in it. So when you see your plan leave cache, its information still in the query store. If that same query comes back through later, instead of making a brand new plan, it can go to the query store and say, hey, we know how to do that already. We've already failed and succeeded and made decisions. Let's go for it. And if it makes good decisions and continues to make good decisions, that was what was in the cache. If things change, then it will revert. And that is a key here too, is with the feedback and persistence piece of intelligent query processing. If there's plan regressions, if it makes a bad choice, it will undo them. See, it's not going to be silly and say, well, I made a bad choice, keep making it forever. That's the whole point of these features, is to not do that. So planned regressions are feedback to SQL Server to say, all right, that choice we made for MDOP, we're going to undo it, we're going to throw it away, we're going to change it. Depending on the situation, it can undo bad choices. If it makes a decision, tries it out, and it gets worse, it'll undo the decision. And so as a result, can IQP make queries worse? Yes, but it'll be temporary. And that's important because we don't want it to make a bad choice and keep it forever. So because it's temporary, it's not really something to worry about too much. The key, though, is this all requires query store. That's important. If you have query store and use it, you've already got what you need. If you do not use query store, though, some of these features will not be available to you. You can't persist information past the query plan cache unless it can go somewhere. And that somewhere is the query store. So if you don't have query store, consider testing it out and turning it on. It's come a long way since inception. I will say it's far, far superior now to what it was in 2016. So if you haven't used it, it's worth talking about. It's worth trying out. It's worth using. It opens up doors to a lot of new features here that otherwise aren't available. And again, there's more sessions today. I've plugged all of them, and it's intentional because we can't talk about everything in an hour, and we shouldn't. So there were 2 sessions earlier today on Query Store, one about hints and one just about Query Store in general. Check out the recordings of those once they're made available later, because they will provide a lot of information on how to use Query Store effectively. And then once you have it being used effectively, you can begin to leverage all these other new features of intelligent query processing. So things like cardinality estimate feedback, you need this. DOP feedback, you need this. So just know that you need Query Store for a lot of these features. And if you don't have it, you simply don't get it. That's key. Kind of often left field in the world of intelligent query processing is approximate query processing. This often gets overlooked because at its core, it's just a bunch of new functions, and people don't always pay attention to those. I do, though, because if you have really large data sets, this can be really nice. So this is a separate thing altogether. Doesn't relate to persistence and feedback and adaptive anything. What this is about, though, is taking calculations that are traditionally slow and painful and making them faster. If anybody here could raise your hands or think to yourself how horrible it was, has tried to have to calculate medians in the past, you had to do it before the percentile, cont, percentile, disk functions were available. You know how painful that was. Making a median by hand, it was like, oh, I have to get the top 50% and then flip it and do this and get the middle. Yeah, it's not fun. You know, doing those calculations is expensive because it involves sorting a large data set. And by nature, it's very expensive. Sorts aren't cheap. It's one of those things you're key look out for in an execution plan if you're trying to optimize something in general is, hey, any unnecessary sorts in there? And odds are, if there are, it's going to be one of those scenarios where your execution plan is like a 97% for a sort, and all the rest is 3%. So these functions here are trying to help us solve the use case where you have an expensive operation and exact precision isn't needed. So a count distinct, for example, is expensive. You got to scan the whole column and get a count of distinct values in there, which means usually caching the value in a work table, getting rid of all the dupes, and then figuring it out. You have to sort it. That's expensive. If you've got millions, billions of values, you're going to wait a while, and not everybody wants to wait. Approximate count distinct is a function that will do it for you faster. Now, obviously, it's cutting corners. That's how it does it. But they guarantee a 2% error rate with a high probability. So what this is really just meaning is that your result won't be exact, but it'll be good. If the actual answer is 1,000, you might get 980 or 1,040, but you're close. And that's the key here, and I'll explain why in a moment. The other functions available through approximate query processing are for medians. Medians are notoriously horrible to calculate. They're inefficient. They're painful because you're forced to not only sort, but then go in and grab the middle, which is even more work. So, depending whether you want the value is in my set or I want the imaginary value in the middle of my set for your median, that's the cont versus the disk. These functions are available. They have a pretty low error rate with a very high probability. And if you use them, the result's going to be that you get a value close to the actual value. You'll get it a lot faster, and it'll use less resources. So using less compute, getting your value faster, and that's generally a good thing. Obviously, if you need an exact answer, if you truly need to know exactly the distinct count of something, this is not for you. If you need to know exact median for whatever reason, this is not for you. But there are many scenarios where exact precision is not necessary. For example, the biggies are dashboards and visualizations. If you're in charge of, if you do analytics a lot and you're creating lots of visualizations and pretty charts and graphs, if people are just looking at that and they're not drilling down to get an exact number and save the exact number somewhere because it's really important, then you don't really need that much precision. You're looking at a chart and the axis goes from, 1 to a million, and you have some curve going through here like this. You're not going to know if it's off by 100 or 10 or even 1,000. You're not going to know. Like, it won't make a difference. You're looking for general trends, and this isn't going to make a big difference. So this is really intended for the scenario where exact precision is just not needed because you want a ballpark, you want a visualization, you want a chart, and the estimates are important. I can't count the number of times in my life where I've wanted to get just a ballpark of, hey, how many of something is there? I don't need to know exact. I just want to know, is it 10? Is it a million? Is it a trillion? I just want to know in general, how big is something or how much of something is there? And for scenarios like that, this is perfect as well because it's approximate, but it's very close, and close is good. So again, these functions are available to make your life easier. They're part of IQP because it's a huge optimization and solves a huge problem that's existed since the beginning of time that involves sorting data. There'll be more of these in the future, guaranteed, but these are the first ones, and they're very helpful. So if you find yourself waiting forever on count distincts or medians, and you can't stand the slowness and you don't need exact, use these functions. They're available for you, they're convenient, and yeah, they're fast. Use less compute. That's huge. If nothing else, you can save resources and time, which no one really ever complains about that. Here's another cool feature, and this is, again, something kind of completely different than what we've talked about so far in IQP, and that is scalar user-defined function inlining. This solves the problem. Again, this is a long-standing problem in SQL Server. UDFs would kind of be a black box. So you would stick a UDF into your query, you'd run it, and it would execute the query, but then the UDF is kind of this black box that has to get iterated through, and it makes things inefficient. So very frequently, user-defined functions in your queries resulted in inefficiencies. Things are slower than they should be. They would iterate when they shouldn't, iterate under the covers. They would do more reads than they have to, and they would just take more time. And that was always a problem. It's existed forever, as long as UDFs have existed. And this solves it. And it solves it really well by essentially taking the contents of the UDF and trying to sub it back into the calling query. So instead of you having a query with a black box in the middle of unknowns, you now have a query with kind of like, for all intents and purposes, a subquery being jammed in. It's not really a subquery, but for purposes of understanding how this works, you can think of it as just taking it and putting it as a subquery, and it's going to execute inline as part of the query. This is a big deal because now when you look at your execution plans, you're not going to see this operator for your scalar UDF that doesn't really tell you anything. You're now going to see the contents of the UDF, whatever is in it, all the tables and transformations, whatever, and you'll see the contents of it. This is useful because you, as a person who cares about data, want to know how your queries are being processed potentially, especially if they're slow or problematic or whatever. And that big box saying scale UDF operator wasn't very helpful. It told you your UDF was slow, great, or it was the cause of your slowness, great, but didn't really tell you how to fix it. But now that you have the contents of it there, you can see which part of it was slow, if anything. And in general, it won't be slow anymore. This will take a lot of your scale UDF problems and make them faster. And this will also kind of begin to change the age-old advice that people gave. People always just said, avoid UDFs, avoid UDFs, avoid UDFs, because they just make your queries slow, right? So don't use them. Don't put them in your selects, don't put them in your where clauses, don't join on them, just don't use them. And that was what we got used to being told for a long time. And if you can avoid making complicated code, I will still always advocate avoid making complicated code. But if you need this, it's a lot likely to be faster now. And it improves performance ultimately by saying, all right, we're going to take all UDF operators that ultimately are iterative and swap them out with set-based ones. This is something you could do too. Like at some point in many of our careers, we've seen somebody write code that was iterative. Go into a while loop and update rows one at a time. And you stare at it for a while and eventually you say, this is slow. Oh, there's updating all the rows. in a table that meets some criteria and doing it one at a time. That's silly. So instead, they can go in and you can rewrite the code instead of a while loop as just a single update, and you're done. And it sounds silly, but these things do happen a lot. People write code iteratively because when you write application code, iteration makes more sense. In the database world, it doesn't. Under the covers, this is the same way here with Scalar UDF inlining, in that it's going to basically make things that were once iterative into set-based. And then all those costs can now be more effectively applied. So not only is this more efficient, but SQL Server can make better plan choices as well. And it will ultimately reduce the number of statements being compiled as part of the query, making things just more efficient. And a big thing here to gain is that it allows for parallelism. So previously, you couldn't use parallelism in queries that had scalar UDFs, because how do you take that out of there? How do you take a black box and put it somewhere? And the answer is you really can't. So it avoided it. It doesn't need to avoid it anymore. And as a bonus, kind of like other features here, like adaptive query processing, if you have a giant query with many, many components, and your scalar UDF is near the beginning, everything downstream kind of got mucked up before, because again, you didn't really have good, valid information about what was going on in the scalar UDF. Now we do. So for larger queries that have things downstream, you'll find compounded gains because now your execution plan is smarter, it knows more, it makes better decisions, and this part is performing better. So this is a very important piece it's an important optimization that was added to SQL Server. And again, if you use lots of UDFs, this will help you a lot. If you don't use UDFs very much, if you don't use your defined functions, it's probably not a big deal. If you do use them a lot, or you have them in your code, whether you like it or not, this will make your life better, and you want to use this feature. So I didn't have a lot of demo today. That was kind of intentional. There are more deep dives going on throughout the day that have lots of detailed demos and just how does everything work. I really wanted to go over why this is important. A big question that comes up a lot, and that is a little confusing, is how do you enable and disable and look at IQP features? Because as core, these are tied to versions of SQL Server. If you have 2016, you're getting none of this. That's just how it is. Now, that's compatibility level. You could be on 2017, 2019, 2022, whatever. You can be in Azure. But if your compatibility level is set lower, you're only getting that. And I advocate in general that you should set compatibility levels when upgrading as a way to kind of safeguard your upgrade and go a step at a time, especially for bigger upgrades. If you're going from like 2014 to 2022, it's a lot of steps. You don't have to do it all at once if you don't want to. You can just bump up the compatibility levels slowly over time. That's really the main purpose of compatibility level and the guarantees Microsoft provides as to performance within each level. That's really meant as an upgrade feature. And we want that. That's useful. That's very helpful. It's not meant to control IQP features, though. For example, if you start using parameter-sensitive plan optimization and realize, wow, it's making bad choices, or hey, somehow I don't really understand how Scalar UDF inlining works. I don't really want it yet. Or just any feature here isn't quite doing what you want, don't use compatibility level to turn it on and off. It's a sledgehammer, and it will turn other things off as well that you may not want off. You can use instead database scope configurations for each feature. So every single IQP feature that is a feature you can turn on and off. Obviously, if you can't turn on and off approximate query processing, just don't use it, I guess. But there's configurations for every single one of these, from CE feedback to DOP feedback to Scalar UDF inlining. All of them have database scoped configurations. And this is huge. This means that at the database level, you can turn on and off things you want or don't want. Now, in general, I advocate testing all of these wonderful features in development in a safe environment, deployment to production. But obviously, things do go wrong. You may have something happen that you can't explain. You just got to turn it off immediately, fix it, whatever. I get it. Things happen at 2 a.m. and we're tired and cranky. We had a great night the night before, whatever. And you just want to fix the thing, go to sleep and figure it out later. So there's many reasons to do this, but you can turn any of these features on and off through database scoped configurations. That allows you to really have fine-tuned granularity without the sledgehammer. And nowhere here are there trace flags. None of that stuff goes on anymore. We're way past that. This is all about, controlling at a database level how everything works. And even beyond that, you can go down to the query level if you want as well. If you have a very, very specific problem, you know it's a problem, you'll figure it out later, but right now at this moment it's giving you trouble. You just want to stop the problem, stop the bleeding. you can actually use query hints to turn on and off features at the query level. So you can simply say, all right, it's 2 in the morning, I've stared at a bad query, I'm grumpy, it's not working, I just want to go back to bed. You can just hit the query with a hint and go to bed. Like all query hints, you should go back and deal with them later. Don't leave them forever, because forever is a long time. We don't usually all mean forever when we do something like this. It's like the people that threw no lock everywhere for years. You do that and then you regret it. This could be regrettable as well, because your code may get better eventually, but if the hint is still there, you're not using a feature that could be very useful. Whoops, not conclusion yet. I do want to just show how this kind of works. It's so valuable. This is really extremely valuable to see how this works. So compatibility level is very straightforward. You set it, and then your database compatibility changes. If I go ahead and I run this right now, my database is now in 2017. So every single IQP feature in 2017 is there for me, but everything else is not. So a good 2/3, 3/4 of the stuff that we just talked about and displayed, it's not there yet, whether I want it or not. I do 150, I'm at 2019, and that's great. I'm fixing a mistake. There you go. You didn't see that. And with 2019, I now have all the features in 2017 and 2019. That's also great. And then if I bring the compatibility level to the most current version, 2022, I get everything. Just keep in mind, though, that your compatibility will keep these things. So if you're trying to figure out and test these, you're not sure why they aren't working, the first thing you should check compatibility level. What is it at? Is it at 160? Is it at 140? Is it something lower? It might be. People often overlook compatibility level as an important thing, but it won't update itself. So if you don't change it and move it, it will stay where it's been. And you can use database scope configurations to turn things on and off instead. This is what I really advocate doing. If you truly have some problem with a feature in a certain database, just turn off the feature in that database for now until you can figure things out. It's cleaner, it's easier, and it's less likely to have negative impacts. You know, if you panic and set your compatibility level back a few versions, you may inadvertently change other optimizer features and slow other queries down. You don't know what you're doing, honestly. I don't know what I'm doing. If I were to take and go from 160 to 130 right now, I need to go, consult Microsoft Learn before I really understand fully what's going on, because there's so many things changing under the covers. I know some of them. I can't think of all off the top of my head. I'm probably going to miss something. So save compatibility level for upgrades. Use these features instead. And what's great here is that there's a view available you can simply use to see all of the details here. This is a list of all the database scope configurations. There they are, all of them. And I can see the changes too that are in here if I make a change. You can also limit it. I wrote a query just for fun here to give me only the ones that are related to IQP. So this is all the IQP features that have database scope configurations, and I can see all the values. Now note that by default here, you can see it. Is value default? This is a useful column. This tells you is the current set value the default for SQL Server. Now do note that by default, they're all on except for DOP feedback. Degree of parallelism feedback is off by default, and only because it's very impactful. It's the sort of thing you may want to test first. It may not in future versions of SQL Server be default off, but right now in 2022, it is default off. So if you're interested in DOP feedback, if you have a lot of parallelism issues in a database environment, you want to turn that on. And we can also just observe changes. I can go ahead right now and see immediately how changes happen. I can just go here and turn CE feedback off right now, go back and look and see there it is. It's now off, and that is not the default. And another useful query to check for is you can say, hey, go ahead and set, I want to look at this view and I want to get back everything that is not the default. And that's useful as well. I can now find out, are there any configurations that I have in my database, this is generally useful, that are not the default value. And I can find out if it's an empty list, great. If it's not an empty list, may ask why. Did somebody mess around here? Is there a reason that's there? Is it a temporary hack? Why is this feature off? I don't know. And again, DOP feedback's off by default. If I want it on, I turn it on. And then I can go back here now and notice that, yeah, DOP feedback being on is not a default. That's okay in this case if I want it. But again, it's worth just noting that these really do give you a lot of fine-tuned granularity, and this is what you want. And there's a lot of them. You could turn off pretty much anything. Like if your multi-statement table valued functions are not performing well with interleaved execution, you can turn it off. That's fine. Scalar UDF inlining, you're not ready for yet for some reason. That's fine. Batch mode on row store, you're not ready for. You can turn any of these off and then introduce them one at a time, or solve a problem really quickly and just get it out of the way for a moment while you figure it out. So any of these features can be turned on and off, and that's useful. And again, this lets you avoid the sledgehammer of compatibility level because it will have unintended consequences, and I don't want unintended consequences any more than you do. All right, so we can go down now, turn this back off, and one final example with fine tuning. This is really the emergency. We all have emergencies. Things happen. You're up late at night. We know how it feels. And so you can disable features at a query level. You can put a query hint like this, and there's a whole bunch of them. And you can use them for CE feedback, DOP feedback, whatever you need. And what it'll basically do is disable it. So when the optimizer goes through and creates its plan, it'll intentionally not use, in this case, CE feedback. It just won't use it. That's it. Done. And that is good. That could be a solution to a problem. If you know that a new IQP feature is giving you trouble and you don't have time to solve it yet, or you want to have some sleep tonight, perhaps, this is the way to get out of it. So I don't really recommend query hints being spammed around heavily in general. I'm usually a person who's more conservative about them, more cautious. Take your time, think about them, use hints when you need them, but only when you need them, and typically you want to plan for getting rid of them later. You wouldn't want to keep this around for years, but as a stopgap while you try to figure a problem out, this is great. All right, it's the end of the demo. I didn't prepare lots of demo, but I really wanted to show the importance of how you can control these features and probably how you shouldn't control these features. Ultimately, database scope configurations are the ideal scenario for this. They let you turn things on and off, and they're not something that requires a restart at all. So if you change database scope configuration, you do not have to go restarting your server or your service or anything like that. It simply begins to work going forward. Anything in flight is going to still be in flight, but anything going forward will begin to honor whatever configuration you put in place. And that is a huge deal. These are not the olden days where you set a trace flag and have to restart your server to get rid of it. Those days are not here anymore. This is much easier. So I kind of want to wrap up here and open it up to questions. I know IQP is a very wide category, has a lot of information in it, and there are many other sessions today that are really going to dive into other features in far more detail. So if you're very interested in one of those features, this is your chance to really dive in head first and learn more about it, and that's wonderful. I enjoy that. That's great. But IQP is a huge suite of features. It's large enough now that pieces get easily overlooked. We forget there's some approximate functions there. We forget about Scalar UDF inlining. We forget about interleaved execution. But you may very well work in a database environment where one of those features is very heavily used. Like you may have lots and lots of multi-statement table valued functions. And if you do, that one little feature with a weird name will suddenly help you a lot. That one little brick in that big chart will now be your lifesaver. So being aware of all the components of IQP is really, really helpful. Even if you don't know how they all work in detail, even if you don't use all of them, that's okay. But being aware of them all is very, very useful because you may not need one of them now, but in the future you probably will. And in general, having them on, and as long as you don't note any huge problems, having them on is valuable. And because of all the new features that involve persistence and feedback, DOP, CE, parameter-sensitive plan optimization, 2022 really has some of the biggest upgrades to intelligent query processing yet. Because they're so wide-ranging. It's not just column store, it's not just batch mode, it's not just a very specific feature and niche use case. These are things that affect everybody. Those three pieces combined can be what saves you or makes your workload far more efficient and everything faster. So it's a really compelling reason just to upgrade. If you're not sure about upgrading in 2022, these features can make a lot of performance nightmares and tuning problems and all that stuff that, we can find joy in tuning a query. That's cool. But we don't really necessarily love doing it over and over and over again. Being the hero that fixes something once is nice, but when you're the hero of the same problem 1,000 times, you don't really feel like much of a hero anymore. You feel more of the zero, and that's not really what you want. So a lot of the newest features in 2022 really take those, you solve the same problem over and over problems and fixes them. So, and these are problems that have existed for years, and not even just the SQL Server. Many of these issues, like parameter sniffing, exist in many database platforms all over the place out there. These are common problems that affect everybody, and maybe there'll be reasons to switch to SQL Server for people because they have ways to deal with performance problems here that don't exist elsewhere. So, um, I highly recommend learning IQP, learn the components of it, how it works, what's in there, how it can make your life easier, and certainly test everything in there if you need to. Like if you have specific problems that you know about, test them, work with them, and see if these features fix them because they will help. And more often than not, very, very likely they will help you and make your life better. And that is really what this is all about here, is making queries faster and making your life a little easier as somebody who has to manage those queries. But I really want to thank you for being here today. This is a cool event. It's a dive into like a part of SQL Server that's getting big and complicated and deserves some attention because it really can help us a lot, especially in SQL Server 2022. If you're out there, if you have any questions for me after this is all over, feel free to reach out or connect. I'd be happy to chat about this kind of stuff in the future. If you have any feedback for me, feedback with persistence, maybe? I don't know. No, just feedback. Just kidding. Just kidding. I'd make a bad joke. If you have feedback for me, though, feel free to provide it to the organizer of this event or to me directly. I'd be happy to listen. And with that, I'm going to kind of hand this, I think, back to Dennis and see if there's any questions out there right now. If anybody viewing right now has any questions, any thoughts on any of the features that are in intelligent query processing, now's your chance. And I'll go ahead and peek as well. I see a thanks. I love thanks. Thanks are great. I do have a little bit of time right now, so I'd be happy to chat and answer questions if anybody has me.
Thank you very much, Edward. A great explanation that will complement all the other sessions that we have today and will make the conference very complete. What's your thought? Do you have a favorite feature in SQL Server 2022?
Oh boy,
Oh,
favorite feature. So I will definitely say that of all the things here, um, the parameter sensitive plan optimization really ends up being it because that is just a nightmare that I know affects me and other people a lot. And having it be able to solve that for you now is nice. It really is. So for me, that was a game changer. It wasn't expected. I didn't see that coming. That was great. I like good surprises, and that piece of IQP was huge. So something that solves parameter sniffing. I mean, I've been presenting on parameter sniffing personally for years. That's a session I've been giving for years. People love it. And now I may put myself out of business. Great. Awesome. I guess I'll present on this instead. But we'll still talk about both because the problem persists and parameter sensitive plan optimization will not solve every parameter sniffing issue, but it definitely is very, very helpful. And to me, at least, that's huge. There are a lot of other new functions in 2022 that I love. I'm not going to drool over it all right now. I'm
yeah,
getting
it will reduce a lot the parameter sniffing problem. It will reduce a lot.
I have a whole other presentation on T-SQL I love in 2022, and it's a long one, and there's tons of stuff in it. So they added a lot of good things in 2022, and I was really happy with that. This is the version that,
Yeah,
I'm encouraging people to upgrade to when they're comfortable with it, at least in like start in development, start in QA, start getting it out there and getting good with it, because there's a lot in there. There's a lot, a lot, a lot.
yeah. And SQL 2022 is being called the most connected SQL version that we have. In fact, there are a lot of connectivity features, but Microsoft left for the last minute to enable those connectivity features on the virtual machines on Azure, don't you think? I mean, on the lunch, I was showing an example of how to enable Azure authentication on an Azure SQL virtual machine. It's not well documented yet. Do you have other cloud connected feature that you like?
The ability to like have the Azure connector and then stretch right on in automatically is nice. I will say the pay as you go is compelling. I see a lot of people testing that out right now and seeing how that works because you can now have kind of like metered licensing, which is new and interesting and has a lot of implications for instances where you have SQL Server running and you don't have a very heavy workload. Like you need standard or enterprise for something. You need it, but your workload is very, very light. You don't want to go paying a mountain of money. And so for certain use cases like that, there could be a lot of money savings to be had.
Yeah, sure.
Somebody did mention in the comments that parameter-sensitive plan optimization does not work all the time, and that is true. It does not solve every parameter sniffing issue. I 100% agree with you on that one, but it's a start, and it gets rid of a lot of them. And so I do appreciate it for that. Nothing's perfect. It's intelligent query processing. They didn't call it perfect query processing. That would be pretty serious, but they don't have that. Scrolling back up
Yeah.
now, and somebody was happy with the Pokemon. I have some Lego Pokeballs back there that I built over the years.
Yeah, people are complaining on the chat
Personally,
that
a
they
fan about
haven't
that.
seen enough Pikachus.
Yeah, I have like Lego Pokeballs floating all around the basement. There's like a mountain over there. There's like mountains of Legos that you can't see them on screen right now, but there's just mountains of them. The kids love Legos. They're always building stuff and having a good time, and it's fun.